Excellent. I think we're recording. Do we have video? Do we have audio? Yes. Okay. Good morning, everyone. Almost. Excellent. Okay, good morning everyone. Just out of interest, can I have a show of hands for people here who are in the Monday prac? Oh, excellent. Okay, I was wondering because your prac was due in by 8 o'clock this morning, how many of you didn't make it. So I want to make sure that everyone in the Monday prac is getting the same access to the course as everybody else. So I encourage you to put some really good time management in place in terms of doing that. That'll be the easiest thing to manage that situation. But make sure that you're not missing out on lectures because you're hurriedly trying to hand in pracs over the next few weeks. Okay, so this morning what we're going to do is so that's a slightly wrong title up there, but this week we're going to look at descriptive stats, and then we're going to look at a few steps that we go through for checking whether data is normal, and what do we do if we find out that our data isn't normally distributed, okay? So the way we're teaching this course is trying to focus on, well, what would you actually do if you were trying to do some research? Some of you might have learnt about t-tests and things like that before, which is tests that you would do with normal data. But what we're doing is we're holding that over until we've gone through a few steps of what would happen when you've done your survey, you're looking at your data and you're trying to work out how should I analyse this. So first of all, you're going to use some descriptive stats to try and visualise your data, and then secondly, you're going to check whether your data is normally distributed or not. And the reason for that is then you'll know which buttons to push in SPSS. So remember, in this course, you won't be calculating things from first principles. It's more about understanding SPSS as a big box of tools. If you were a carpenter, it would be a big box of carpentry tools. You just have to know which tool to use for which job. Okay, that's a very applied approach. So anyone that's new to statistics, you can be confident that what you have to learn here is simply about which tool to use for which job. Okay, so I'm going to change that title and reload that up again. But here we are in week 3. And you should have all started or virtually completed prac 1. So what I want to do today, as well as looking at descriptive stats and preparing for the next week's prac, or prac 2 rather, is also show you an example of a survey using a Likert scale, which we've come across now in prac 1. Where we ask people to circle a number between, very important or not important at all, or very satisfied or not satisfied at all. I'm going to show you a couple of examples of that. It might give you some ideas for things that you want to investigate as well. We're also going to introduce a few terms that some of you might have seen before. So N is simply the number of observations in a calculation, and P is the probability value, which we'll give you more information on later. But for this week and for this prac coming up, the main thing that you have to think about in terms of what is P, P is deciding whether or not we accept the null hypothesis. Okay, I'll fill you in with more detail on that as we go along. But from a practical perspective for week 2, for practical 2, it's simply looking at the p-value and using that to decide, are we going to accept the null hypothesis? I'll remind you of what that is again in a second. or do we say that there's not enough evidence to accept the null hypothesis? Okay, I want to show you these examples. So this here is a survey that was done asking people along the Portneuf River in North America how, for their preference or their vision for the future for this river. So we had, this is an urban area, it's growing fairly rapidly. It's still pretty small, but like a lot of North American cities, the river was channelized in the middle of the city during the 60s, 70s. And so looking forward, they're sort of planning, they're wanting to plan, well, what should we do with the river? Any of you who've seen these sort of dechannelization projects before, you'll know that they're incredibly expensive. So you really want to make sure that you're in step with the public before you start to spend that sort of money. My personal preference is I would love to see rivers not channelized wherever possible. But of course, you don't get to do any work if you're working completely against the public interest. So this is the results of the survey. Oh, I've just gone to the bottom somehow. So this is the results. It's not the actual questionnaire. It just came out in 2016. And you can see here, it's a good example of how you might set out results from a survey. So even though I said last week that you would put the demographic questions towards the end of a survey usually, when you're reporting it, it's a good idea to put them up front so that whoever's reading knows exactly who the audience is that you're talking about. So here we have a spread of ages, and they've highlighted the largest groups, how long they've lived in the area, that sort of thing. These are general sort of demographic stats that you might gather in a survey. And then they asked for what are people's sort of concerns when they're thinking about the river, and they wanted them to rank their top two. So you can see there that number one, by a massive majority, was water quality and ecosystem health. Number two was then increasing access and public use. So by having that question in the survey, I want you to keep thinking about, well, why would you put a question like that in the survey? What are the concepts you're testing? What are the decisions you're trying to make? So here, by having these questions in there straight away, we know that there's a general concern amongst the vast majority here, very significant majority, when they're thinking about the river, they're thinking about water quality and ecosystem health. And secondly, they're not just thinking about it from a preservationist sort of national park approach. They're thinking about it in terms of the river is something that we want to access and we want to use. We want it to be healthy. We want the ecosystem to be healthy and the water quality to be good, but we also want to use it. So that provides you with a bit of a filter for interpreting some of what follows. So these are the questions I really wanted to show you because I think it's brilliant the way it was set up. Some of you might know a little bit about scenario planning. Scenario planning is a fantastic way for sort of exploring plausible futures. Okay, it's been done with things like climate adaptation research. And here we have it looking at a vision for an urban area and the river in that urban area. So what they did was they set up a Likert type scale. You can see there from love it to hate it. So they've put it in terms that they think are going to resonate with the people that they're interviewing. And even more so, I'll show you the scale at the bottom here. So -3, so on their survey they would have had a list of numbers like that, and then they had those photos, which I'll go back to a second, and they had to circle which number from hate in -3. I like this one, kinda dislike, which is -1, kinda like, and so they've tried to make it as informal as possible so that you're not setting up any extra barriers there with the way people are responding. I'll go back to here. So this question is asking them to imagine the river years from now. As you think about your vision of the river, what type of land use would you like to see more of along the river near Pocatello? That's town. And so then they rank it. Now, just like what you were looking at in Prac 1, where we had an average, a mean between 1 and 4 for how important were different facilities in the parkland in Anchorage. And then we had 1 to 5 for how satisfied. Here we've got the mean, or the sum, the mean of that ranking scale at the bottom here. So you can see here that it's possible to have a negative. So you've got 2 slightly negatives, a slight positive, and then some stronger positives there. Before I ask for your opinion, I'll just go on to the next one. So you can see here, though, that by doing it this way, you can give people a photo, and you know, there's that saying, a picture is worth 1,000 words. There's a lot in each of those visions, and that these photos have been selected very carefully to represent certain decisions that could be made around this river. So I'll just show you this one, and I want you to talk to the person next to you about, have a look at this one here, which, is it that one? I might do this one. Yeah, I think I'll do this one. So this one is about the parks along the concrete channel. Sorry. And now I'm showing you all the other ones. We'll just do this one, this top one, sorry. So here we've got trails along the concrete channel. So you've got 6 different options there. Have a think about which one you would prefer personally. Okay, have a look at those. So you've got trails along a channelized river in the middle of a town. Do you want a trail next to a concrete channel? A trail covering the concrete channel, so pipe in the river. Put it within the concrete channel, etc., etc. Have a look at that and think about which one you would prefer. So I'll call out the numbers. I'm interested to see what you all think. So number 1, you can put your hand up when I, so this is number 1 in the top here. I'll call out the numbers and just give me a show of hands so we see what you all think about this. So number 1, trail next to the concrete channel. Number 2, trail covering the concrete channel. 3, trail within the concrete channel. Number 4, trail within concrete channel with natural elements. 5, trail within concrete channel with grass. And then 6, trail within concrete channel with natural elements. Okay, yeah, so you guys fairly roughly fit this community in terms of this question. This is a fairly simple question, isn't it? What do you think it's testing here? What might be sort of the variable that they're looking at there? There's sort of an obvious one around design, and that's about the relationship of the trail and the channel. But look at those pictures from 1 to 6. What's varying across 1 to 6? The relationship of the trail and the concrete channel according to... Yeah, I'm hearing different versions of the same thing, I think. Around the natural elements and the inbuilt. So you've got that question at the top here. Let me just go back to that I showed you before. The one where they said 73%. Have I lost that? Anyway, here, sorry. 73% were interested in water quality and ecosystem health. And so once you've got that question, and then you can compare it with the answers to that picture version of that, you're sort of doing what we call, you're doing triangulation. So you're asking a similar question in different ways, and then you're able to say something more robust about the results there, because you've sort of come at them from a couple of different directions. Okay? What about down here? What sort of, here's the parks along the concrete channel. Have a look at that and just have a quick chat to the person next to you. What of those visions of the future for what's currently a channelized river in the middle of a town, which one jumps out at you as the sort of town you would like to live in? Okay, pick a number. I'll give you 10 seconds to do that, and then you can have a quick chat with the person next to you. Okay, just a couple of minutes to talk about that. Which one do you like and why? Okay, now I'm interested to see what the spread of results is this time. We'll do a quick show of hands, and then for those of you who want to share some of what you were talking about, that'll be really interesting too. So I'll go through the numbers again. We'll do this fairly quickly so we can see what sort of diversity we have in here. So that first one there, number 1. Really? Number 2? That looks like no skateboarders here. That looks like a great informal skate rink. 3, 4, 5, 6. Okay, so it looks like you're fairly roughly spread across a little bit of 3 and 4, 5 and 6. Can I just get some quick feedback? What about 1 there? Why didn't number 1 jump out at you? Does anyone want to share their thoughts on that? Yep. You didn't think it was very clear? Okay, well that's really interesting. It's hard to see the detail. Yeah, I guess when you're actually doing the survey, you can give people like a A4 or A3 size photo, and then that might help to communicate that. But that's really interesting feedback. Yep. Yeah, okay, yeah. So it looks like, well, there are a lot of people using it. So it's obviously measuring that, you know, what sort of level of use would you like to see of the river? But then it looks like perhaps it's eroded a little bit because of that. Okay, good, yeah, and there are sort of a few kids right down there on the banks of the river, actually. So maybe they're checking perceptions of risk as well. I guess what I want to get at there is that we have a scenario here that's very plausible. There's a whole range of elements going on in it, but we can encapsulate it into one picture and get people's opinion on it. Okay, what about, let's go to the other extreme. The people that picked number 6 there, why did you pick number 6? Anyone want to share what you were talking about there? Yep, down the bottom. Yeah, so you like the idea, particularly if any of you have lived beside a channelized river, you kind of get those extremes. Some people say, oh no, I want you to keep it channelized. Some people say, no, I want you to put it back. And often, unless you're concerned about flooding, you'll probably want to see it put back. Okay, there was another hand that I saw go up to Amy. Yeah. Yeah, good. So you can see that maybe they've got a bit of a typology going on where they designed this, and they've got a, 1 and 6 have a lot of human use, but one's got more natural than the other, it's got more rock than the other, that sort of thing. Okay, well, what about in the middle? Anyone that chose 3 or 4? What sort of things jumped out at you there? Why did you choose that? Up the back? Yeah. Yeah, good. So we don't know what the housing looks like around this river. If this is medium to high density housing and you were interviewing people that live in that situation, I lived with my daughter in a 1-bedroom unit until she was 2. I would have probably circled number 4 in a heartbeat while I was living there because we needed somewhere to get out and run around, that sort of thing. So yeah, you can see that there's going to be a huge diversity of interests in public space. Public space is becoming more and more sought after in our cities, and this is a way of trying to simply capture all the diversity in the community around the sort of design they might want to see. But it's not just about design, it's about the actual interests and use in the space and accountable investment of public funds to do it. I want you to just have a reflect on this way of doing things. What do you like about it? And what do you have questions about or you think might be a challenge about that? That was very quick. Up the back there. Yeah, good. Okay, so what so that's a good point. This is a visioning survey, so it is really high level. And so especially where you might have a lot of diverse opinions, you might go through a planning process here where you try and cast a general vision, but then you're absolutely right. Before we invest any money, we're going to have to do up some more specific technical designs. Depending on the city that you're in, you might set up a panel of community members to be involved in fine-tuning that and developing some different options there. Good. Any other comments? It's all very what, sorry? Yeah, that's true. Yeah, this is the area right in the middle. I didn't get a chance to show you the whole survey, but they do ask about sort of agricultural land and that sort of thing later as well. But I think this was the big ticket item in terms of how should we spend your money, and it was a bit of a political hot potato. So it's also about covering your bum as someone responsible for public decision making. Do you think, what other challenges, what about this sort of approach of putting a score like this against the photos? Do you think it's good? Are you not so sure about it? What do you think's good about it? What aren't you sure about? So do you think it's too suggestive, it's too biased, or, yeah, I mean, in the end you are framing some different options. Yeah, I would say that I find this a really interesting approach in that you're able to capture sort of the feeling or the vision and get people to think about what sort of future they might want. Of course, once you start get down to the details, I think that's the challenge around this, is everyone's interpreting that photo in slightly different ways for slightly different reasons. So you might come up with a lot more diversity and things you have to work through later on. But for those of you who are in planning, you'll probably start to recognise these processes where we try and get high-level general agreement about something and then sort of work forward like that. If we try and jump to a specific solution, which often happens just out in the political arena, it's much more difficult to get that sort of broad buy-in. I want to move on now, but I guess I wanted to just draw your attention to the fact that this is quite a complex concept, and often Likert scale questions are about constructs, concepts, categorical variables. So remember, a nominal variable, so they don't have much data within it. If you just ask people, yep. This is the result of the survey in that it's got the scores up there. So usually you would have the questionnaire, the question up there, sort of rank the following photos, blah, blah, blah. You can see that this one doesn't have a title on it, so you're just wanting people to look at the photo and make a judgment. But yeah, they're the results of the survey. Yeah, yes, that could be the case, but I guess in this situation, this is a picture version of moving along a spectrum, I guess. So yeah, you're right. In some situations, you might want to randomise it, but in this situation, you might say, well, I actually want people to clearly note the sort of level of naturalness that they want in that design. But you can see some of the challenges there as well. There's arguments about this being a bit too much of a sort of simplistic approach, that we bring things down, a very complex situation, bring it down to a simple number. And then the other side of the argument is, well, if we set up a spectrum, we can actually take this categorical sort of nominal variable, and we can then treat it as an interval variable and do different statistics on it. There's still a debate amongst statisticians that I'm happy not to be part of about whether a really well-written Likert question generates interval data. So that means you can use the scale to say it's got a category, it's got magnitude, and it's also got interval, so the differences between your categories are fairly even. If we can do that, then we can do a whole range of statistical tests on this, which is often good when you're talking to people who manage money, if you can say something as specific as possible. But in the qualitative lectures, we're going to talk about how you might need to complement that sort of approach with something that also shows decision makers the real richness and diversity in the data as well. Give them something simple to think about what's the significance here and how much should we invest into these different options you've come up with, but then try and show them the diversity of the real world that you're dealing with as well. Okay, there was one other thing that I wanted to show you, and I've got this on Blackboard. I think I'll just go to it here. So I want you to, this is a great resource to have a look at, and there's a list here of a whole range of ways to do a Likert scale. So obviously the scale that you select, if you want that to set up the closest you can to some sort of interval data, it needs to be matched in really carefully with the question you're asking. So level of acceptability, if you're asking about beliefs, here's some ideas. You can see some of them go 1 to 7. And some of them go 1 to 5. So over here on the right, you've got a 1 to 5 for level of support, level of probability. Now it's really important to think about the exact wording that you're putting in there and to pilot any research that you're doing to make sure that people are hearing what you want them to hear when they're reading these words. But this is just a good sheet to have because someone's gone through and done a lot of the thinking for us around what are some sort of general Likert scales that we could put together. So I encourage you to have a look at that. Okay. So what we're going to talk about now, and we've introduced it already in Prac 1 a little bit last week, is this idea of descriptive statistics. For many of you, you've come across this before. Maybe you didn't call them descriptive stats, but it's really about summarising, simplifying, and describing the measurements. So you've done your survey, you've got your results back, and you want to do some sort of preliminary overview at what results you've got. So you're not yet testing the hypotheses, you're simply summarising the data and looking for some patterns in the data. And the reason, I want you to keep asking me if I'm telling you something, you're saying, but why would we bother doing that? Okay, because this course is about applied research methods. The reason we want to summarise the data is we're looking for particular patterns or qualities, and it's helping us to think about, well, how would we actually analyse that? And I'm going to introduce this term a bit later. One of the big things we're trying to work out is it parametric or is it non-parametric? Don't worry too much about that term. If you haven't heard it before, I'll explain it as we go. But in your mind, I find this helpful when I was learning stats, was to sometimes you can set up like a tree diagram where you can write yourself a summary of these sort of lectures and you say, I've got my data. Is it normal? Yes, do this. Is it not normal distribution? We can use that tool, and then you can create yourself a sort of chain of decisions. It's a very practical thing that you can use in your own work, and also for your assessment later on. Okay, so for example, the mean, the average age of respondents, which is something that you looked at in Prac 1, is a descriptive stat. It doesn't test a hypothesis, just tells you something about the data. You've probably all heard of this, especially if you're in the lecture last week, mean, median, mode. So these are descriptive stats about the centre of a distribution. I'm assuming that people have come across this before, so I'll go fairly quickly through these. So in this particular sample, you've got a mean of 30, you've got a median of 28. Now, always there's someone that asks, what do we do when we go to find the middle value and there's an even number of values? And so you get to the middle and there's two values, you average them and use the average of those middle two values as the median value, okay? And here's the mode, 27 is the most commonly occurring one, or another way of putting it, the one with the highest frequency. Okay. So everyone's heard about averages before. If you're into sports, then batting averages, average test score, etc. And then we need to talk about this thing of outliers, which again most of you would have heard of before. So here we've got two samples. The top one has a mean of 30.6, and the bottom one 23.9. The medians, though, you can see, are slightly further apart in the bottom one, and that's because obviously there's no other data points between 24 and 44, so the question arises, is 44 an outlier? Is it skewing all our stats? We can see here that it is definitely skewing the mean, but we need to know, well, by how much? Does it mean that, the results that we're handing to decision makers are not as accurate as we want them to be, because 44 is a bit of an aberration? So let's use the example of median house price, which is a great example of how a few outliers can skew the mean, the average value. So this is 2015 stats now. I don't think houses have gone up too much since then in Brisbane, happily. So the most expensive, so the furthest up the end of the spectrum was 14 million in May 2015. Was that a show? Was someone asking a question there? No? Okay. No one wants to buy this house. But the median is 513,000, okay? So median, if we could order all the houses that have been sold in Brisbane over this time, we can go back to the middle, and we get to 513,000. And again, we're saying, well, so what? We need to use this in an applied way. And the thing is that we need to be able to identify those outliers. So the mean's calculated value, median is interested in the distribution of the values, and you've probably seen that before. The idea of a range is the whole range of all the values from the lowest to the highest. So the difference between 22 and 44 is 22. Now, can I have a show of hands? Have people heard this term before of interquartile range? All right, I better make sure I explain it. For those of you who've seen it before, this is revision. You're kicking goals in this course. Okay, so once we've got everything ranked in order, all our data points, we can then divide them. So we've got the full range. We can divide that into quartiles, so quarters, basically. We do this. The first quartile is the lowest 25% of the data. So that's from that 27 point down. The second quartile is the middle 50%, so basically from the median down. And then the third quartile is cuts off the lower 75%. Okay, so you can you see down the bottom there, instead of third quartile, you might see it written as Q3. You don't have to worry too much about calculations from first principles there, but what you need to know in a practical sense when we're trying to work out, is that extreme value an outlier? Should we disregard it? Is it skewing all of our descriptive stats? Is we need to know what's Q3 and what's Q1, okay? And the difference between Q3 and Q1 is the interquartile range. So basically, what you've got here, that's the lowest 25%, that's the highest 25%, this is the middle 50% of our data points, okay? In this case, the interquartile range, we take 34, which is Q3, subtract 27, which is Q1, and we come up with an interquartile range of 7, okay? Is there any queries about that? Okay. While I remember, for this week and from this week onwards, I've also got a link under if you go into the week 3 lecture slide, there's a link there which will take you to a wall where you can post the muddiest points from the lecture. So if you walk out of the lecture and you think, oh, actually, I wish I'd asked that question, you can put it on this page. That's really helpful for me in a few weeks when we're trying to revise. We only do about 3 weeks of this, especially focused on statistics. And then if I've got your comments on that page, it helps me to know what we need to go back over, okay? So I still would like to hear from you in the lecture, of course, but it gives you another option. Okay, so what we're going to say is that an outlier is numerically distant from the rest of the data. So we had that $14 million house, and we can use this idea of an interquartile range to identify whether it's an outlier or not. Remember, again, in a practical sense, you want to have the best overview in your descriptive stats for yourself and also for handing on to decision makers. Descriptive stats are some of the easiest ways to give non-technical people an insight into what you've found. So here's an example, and I wouldn't mind a show of hands on this one actually. Just from looking at that, there's the interquartile range between 27 and 34. And then down the bottom there, we've got 22. Who thinks that 22 is not an outlier? Who thinks that 22 is an outlier? Who doesn't want to put their foot down at the moment? Okay, so we can use this idea of an interquartile range to work out if these things are an outlier, and this is how we do it. What we need to do is work out a lower fence and an upper fence. So we've got the interquartile range here between 27 and 34, sorry, that's the distance between 27 and 34. And what we're going to do is go Q1 minus, remember our interquartile range is 7, between 27 and 34. So we just do this simple formula. Q1, which is 27, 7 interquartile range. We multiply that by 1.5, and then we say we're going to go from Q1, we're willing to go down another 1.5 of this interquartile range. Remember, that's the middle 50% of the value. So we're willing to go another, that distance and half again, and then say anything past that is an outlier. Okay? It's actually fairly conservative. And then we would do that from the other direction as well. So an upper fence, we would go, here's Q3, 34, the interquartile range, it's still the same, it's the same sample, 7, multiply that by 1.5, and we get 10.5, and we say we're willing to go another 1.5 of that distance above Q3, and it has to be more than 1.5 above that, 1.5 of this distance, sorry, before we say it's an outlier. It's a bit of gobbledygook, but did people understand that? Actually, I don't know about using that word these days. Okay, what we find when we work that out is that if I'd asked you, is 44 an outlier, people might go, we have to work that out. And you can see that 44 is just inside, okay? So we would say in this case, 44 is not an outlier. When we're doing our descriptive stats, mean, median, mode, we can include 44 in the calculations. It's not, you know, an extreme value that skews everything too much. But then what about in this situation? Show of hands, who thinks 44 is an outlier in this situation, just from looking at it? Okay, a few more people here. So we can do the same thing. Lower fence, Q1 minus 1.5 times the interquartile range, and then upper fence, Q3 plus 1.5 times the interquartile range. So to do that, we obviously have to work out Q1, Q3, and the interquartile range, the distance between those two. Here we go. In this case, there's a whole range of 22s, and you're going to find out the 22 that is a quarter of the way through your whole data set. Don't worry about the fact that there's a whole number of 22s. We're just looking at the ranks, okay? Then 23 is Q3. And so in this situation, the interquartile range is only 1, okay? So you can see that when you've got a sample where you've got a whole range of the data is very much skewed down on the left-hand side here. They're piled up on the left, which means, well, I'll get you to say in a minute whether that means it's positive or negative skew. In this situation, 44 is going to be an outlier. Actually, anything above 24.5 in this sample is an outlier. So if you just kind of assumed, oh yeah, 44 was right last time, it's probably right this time, you're going to end up with results that are way off base, okay? Some of you picked up in Prac 1 that there were a few errors in one of the questions. There was like a 22 where it should have been a maximum of 4. So some of the times when we have an outlier, it's simply because data has been entered incorrectly. And so it's really important to find those. Sometimes we have those outliers because you have an extreme case for some reason. But again, with our descriptive stats, we need to pull that out. If you're a case study researcher, which Christine will talk about, you might actually, that number 44 might be really interesting. We might want to understand why is this up here, because that might be something really important that we have to explore and examine. But I'll leave that for Christine in some later lectures. Okay, I want to do a couple more slides and then we'll stop for a quick break. Some of you might have seen box and whiskers plots before. In the middle here, there's the median, there's Q1, Q3, and there's the entire range, okay? Here's a similar one, but here we've got the outliers in here, okay? Sorry, that's probably not the entire range. That's the lower and upper fence, and here's some outliers, Okay, that's a way of symbolizing that. You can do that in SPSS. Some of you would have seen that pulled up in Prac 1. Okay, I just want to zip through this stuff about standard deviation, and then we'll stop for a very short break. When we stop for a short break, I'm going to get you to think about, I'll just give you this little bit of notice. I'm going to get you to think about if you registered for interest in a peer learning group, what sort of times of the week would you be interested in meeting in those groups, okay? For those of you who are here today, this will be the quickest way to just sort of roughly do it now and get you in your groups, because from this week onwards, you're going to have some people that are going to want to revise and clarify the material a bit more. Okay, so dispersion of data, we've already talked about the range, and you're probably familiar with this idea of standard deviation. So we know about the range, and that was the case before, between 22 and 44, the range is 22, because that's the gap between the two. In this situation here that we had before, the outliers greatly extend the range, and so then it might not be that useful to talk about the range being 22 in this situation. So what we can do is use the standard deviation. You don't need to calculate it from first principles in this course, but this is how you would do it. So the standard deviation is a measure of the spread. You might have learnt this before, you may not have learnt it in English before, but this is what it is. You simply calculate the distance from the mean of every data point, so you know how to find the mean, and then you calculate the distance of the mean from every data point, you square them, you add them, then divide by the number of points, and then take the square root. Sounds simple, doesn't it? Luckily for us, it is simple because we push the right button in SPSS, does all that for us, okay? But very briefly, so that if you're not familiar with this, you can go back over it and look at it later. The first thing you obviously need to find out is, well, what's the mean? You know how to do that. Everyone knows how to find the average. In this case, 30.06, we can say that's 30. That's close enough. Then you go through. This is what I meant by finding the mean deviations. That's every data point, and that's the mean, and that's the distance from the mean, okay? So you find the mean deviation. Then you square them all, so they all become positive. Then you add them all together, which becomes 543. Then you divide by the number of data points you have, and that becomes 36.2. And then you take the square root of that, which becomes 6.02. Aren't you happy that we now have software that does a lot of that for you? It's actually fantastic in terms of the field of research. We can get a lot more done. The downside is that's why the graduate school at the university wants you to finish your PhD within 3 years, rather than they used to let you go for years and years because we didn't have tools like this to crunch data and locate data as quickly as we do now. If anyone wants to know what happens if you go longer than 3 or 4 years, you can talk to me later. You start getting some interesting emails from grad school. Standard deviation. Just a little bit of language. You'll see it written as SD or StipDiv, and sometimes just S. But for our purposes, it's just telling us, well, what sort of spread of the data have we got away from the mean? So the smaller the standard deviation, the closer all of our data points are to that mean. The larger the standard deviation, the further away that spread is from the mean, okay? Again, you're saying, why do we care, Paul? We want this to be a practical course. And the reason we care is because if we know that our data is normally distributed, then we can use the standard deviation to really quickly estimate some things about our data. And you'll see expert researchers able to do this really quickly and interpret something of what's going on straight away. Now, some of you might be familiar with this. I already mentioned normal distributions last week. This is how we would use a standard deviation to say something useful very quickly about our data if we knew that it was normally distributed, okay? Again, if you're writing your little tree diagram for making decisions, this is what you would do when it's normally distributed. So we know the mean and the median. This is reminding you about normal distributions. Mean and median are equal. 50% of the data is on one side of the mean, and then therefore 50% is on the other side, and the data is symmetrical. We have this really nice bell curve. If we were if it was, we were able to map it like that, and you can see there, straight through the middle, it's symmetrical either side. And so we can use the standard deviation to roughly say a few things here. Does anyone know what these numbers mean? 68, 95, 99. I've kept it a bit obscure. Is that a hand up? Yep. Excellent. So this is how you can use it as a fantastic shortcut. If we know that it's normally distributed, we know what the standard deviation is, we can really quickly work out what percentage of our data is likely to be where away from the standard deviation, okay? It's really useful. So here in this example again, that is one standard deviation, okay, away from the mean, 2, 3. And so we know that 2/3 of our results in this situation are going to be within just one standard deviation of the mean, okay? We know that 95%, that's one of the magic numbers that we'll come back to a bit, is within 2 standard deviations of the mean, okay? And 99% is within 3 standard deviations of the mean. So you can look at that really quickly and understand something quite useful about what's going on. Once we start getting into statistical tests, you will know that we might say 95% might be what we're looking at to decide whether a null hypothesis, whether we're going to accept it or not. If you're dealing with something where people might die if you get it wrong, you might go to 99% before you say we're going to, whether you're going to accept or reject the null hypothesis. So how sure are you that the data point that you're looking at is, within what, I'll get to that later, I better not try and explain it right now. But basically, this is the pattern that you can use, and then you can straight away say, well, the vast majority of data points are going to be between here and here. Here's an example. Test yourself. Here's the data. There's the mean. So if this data were normally distributed, 68% of values would be between what and what, and 95% of values would be between what and what. So we'll stop for a short 5-minute break there. People who want to work that out can, and I'll show you the answers in about 5 minutes, okay? And remember, also in the break, jot down what sort of roughly what time of the week you would like to meet with a peer support group. Because at the end of the lecture, I'll say, okay, you guys over here, you guys over here, and see if you can actually put a time on, and then it'll make it easier for everyone to get started into those groups. Okay, 5-minute break. We'll start again by this clock at 9 o'clock. If you have any questions, feel free to come and chat to me now. Yeah, I will do. Usually I do that simply because like for once I was but there are people doing that last year, so I will try to do that. Okay, no worries. Thank you very much. Yeah, for sure. Okay. We're going to revisit it, but I'll just get a quick show of hands for the times of the week that people are interested in. First of all, remember we have two types of groups. We have groups where people are mostly wanting to focus on the content of the course and revising, and then we have people perhaps who've been in the workforce for a few years and they want to sort of reflect from that perspective and sort of extend themselves. Both of these groups, I would encourage you to do reading, to read and to think and reflect and build up these skills. But obviously we have a big diversity of people in this book. Okay, so in terms of the revised groups, there was about 70-something people that signed on to that link on Blackboard that said that in theory they're interested in these groups. I just want to show of hands for what days of the week. It's not going to work. This is the real tricky bit. What days of the week are people most interested in? And let's just say morning, middle, and afternoon. Okay. So first of all, Monday for revised. This is revised. Okay. Monday. Not sure. Tuesday. Wednesday. Yeah, using your voice as well. That's extra voting. Wednesday, Thursday. I'm not going to do it after the lecture. That would be a good idea. Friday. Okay. So I can see moderate support for Tuesday, Wednesday, Thursday were the most common ones. So can I have Tuesday? I'm going to do 3 morning. Tuesday middle of the day. Tuesday afternoon. So now this is where everyone gets spread apart. Okay. Wednesday morning. Middle of the day, afternoon. Where have you all gone? Thursday morning, middle of the day, afternoon. Okay, so Thursday's getting some more clear clusters in terms of morning, middle, and afternoon. And what if I just say generally, we would like to meet in the morning? Is that too hard to say? I don't know what the timetables are. Who would like to meet in the afternoon? Okay, looks like sort of middle of the day. It doesn't matter, it changes every day. How are we going to do that? So we can have up to about 5 groups, I reckon, with 70 people. When you think that people don't always come, people might get busy as we go along. So what I want to do is I'll actually get you at the end of class. For people that want to be in a revised group for Tuesday, Wednesday, or Thursday, you can meet on. Well, you're the majority of people, okay? So we can have Tuesday. When Thursday is the big one, so Thursday people can sort of congregate here. Tuesday and Wednesday, okay? Did I say that right? Thursday, Tuesday, Wednesday. Extend, there was about 20-something people that were interested in that. So the extend people, you can just meet over here afterwards, see if we can come up with 2 time slots during the week that people are interested in. The idea of this is to we want to be able to post those times on Blackboard so everyone knows. You'll be able to use the Facebook group to contact people if you want to join in later on or change groups or whatever. But obviously by week 3, we just want to have a go and get started. If you find that a group isn't happening at any time that works for you, jump on Facebook and say, is there anyone that wants to meet at these sort of times, okay? I think I'm going to have to leave it a bit up to you in terms of using Facebook and email to do that. For external students who are listening to this recording, we've got those 2 online sessions for you, and I'm assuming that you're pretty much one peer learning group. It's structured across those 2 forums. Okay. Did anyone have a go at, so I'll do that at the end of the lecture, don't forget. Did anyone have a go at working out where 2/3 of the values would be in this situation here? We've got a mean, we've got standard deviation of 6.02. Did anyone have a result for the 2/3? No, you're volunteering someone to say. Okay, well, see if you got it anyway. Okay, so remember, 2/3 is going to be within 1 standard deviation of the mean. Okay, again, if you're not quite sure about what this standard deviation thing is, for our purposes, it's a number in SPSS after you push the right button. Okay, so between 24 and 36, because the standard deviation is 6, so it's 6 either side of the mean, 30. 95% is then going to be between 18 and 42, which is 12 either side of the mean, which is 30. Okay? So that's a good thing to remember when you really want to quickly understand where your data is. Okay, I can move quickly through this because we've already talked about this in Prax and last week. But again, you're saying, Paul, why are you making us understand this? The reason is that because not all data is normal. This is what Prac 2 is going to be about. How do you check whether the data is normally distributed? And if it's not normally distributed, we can't make that same estimation that we just did, and we have to press some different buttons, use some different tools to say something significant about our data. So we know that data can be skewed or it can have kurtosis. I'll leave that to you for you to test yourself. Are positive values for skewness piled up on the left or the right of the distribution? The clue there is that last week I explained it in terms of the tail. Which way is the tail pointing? This time I'm saying, well, think about your data, which is actually more meaningful for you as researchers, on which side of the distribution are most of our points piled up if we've got a skew to the data, okay? Test yourself on that. But basically, positive skew has a tail pointing towards a positive infinity, and negative has a tail that's pointing towards negative infinity on the x-axis. Kurtosis, we said before, is about how flat or pointy it is, and it also has to do, that influences the how much of your distribution is out in the tails of your probability function there. So there, when you've got a negative or a low kurtosis, it's going to be flatter, and the tail is going to be shorter, okay? So less data out at the extremes. If it's got a positive kurtosis, it's pointier, and it's got more data with the relatively long tails, okay? Now, again, you're saying, well, that's really nice, but why? How can we use this practically? Again, when we're thinking about different factors that we might be researching and what we might be expecting to find with something like this of mortality rate within hours of hatching for turtles, over here on the left, you can see that, you know, you get in that first bit of the journey from the nest down to the ocean. If you've seen all of those very gory nature documentaries with the race of these cute little baby turtles and everything eating them as they go down there, we would expect to see that a positive skew here. So we've got a tail pointing towards positive. Whereas in weight of a mature sea turtle, we would hope to see some sort of a normal distribution, fairly symmetrical, and we would be able to say something, we would use different statistics on either of those. Okay, so that's how you can use it to just quickly eyeball your results and say, well, is that what we were expecting? And then straight away you might have a finding that you can put in your report, whether you found what you're expecting or not. Okay, this last part of the lecture, I want to talk about what you need to do for Prac 2. Okay, remember we're approaching this from an applied sense. So you've done your survey, you've got your data, and now you need to check, is this data normally distributed? And we need to know that so we know what tools we're going to use to analyse it. So there's 4 ways that we're going to use. You've already had a quick look at 2 of these in Prac 1. We're going to use 4 of these in Prac 2. And then I'm also going to talk about what we do if the data isn't normal enough. And this is where we use a different type of test. Okay? So first of all, eyeballing, you did this in the first one. That's not the official term. It's just basically look at the histogram of the data. Does it look normal? Perhaps put the curve over the top. Have a look at it. How well does it fit that curve? Obviously, that's a little bit subjective, isn't it? So then we can start to say, well, is the data normal enough? And I showed you these slides last week, and you looked at this in Prac 2, where we say, well, how skewed is the distribution? We can look at the descriptives in SPSS. So here's our here's our skewness statistic. Here's our standard error for that skewness statistic. We need to standardize it. So the way we do that is we divide that by the standard error and we come up with this standardized number, okay? I showed you the table last week to help you interpret what this means about whether it is too skewed for us to call it normal. And the answer is yes. If it's more than 2 or less than -2, in general, we can't consider that distribution to be normal, okay? Again, you'll start to see these patterns, okay? This is analogous to 2 standard deviations, okay? We've standardized it. Remember before we were saying more than 2 standard deviations away from the mean we're going to have 95% of our data within 2 standard deviations. So what we're saying here is if our z-score is outside of that, it's more than 2 or less than -2, it's too skewed for us to use the statistics we would on a normal distribution, okay? So you're going to be looking at those skewness and kurtosis scores in the prac anyway. It'll make more sense as you go along. Now this one's new for some of you. Has anyone seen the KS test before? Another way if you want to, so what they do in statistics, like a lot of things, is they'll name the test after the person that came up with it. In this case, there's 2 people's names. You don't have to be able to memorize their names. You can shorten it to the KS test. Some people call it the vodka test because of this guy's name here. Actually, I'm assuming they're male and that might be wrong. I apologise for that. But what you need to know now is now we're heading into a slightly different area of, instead of just descriptive stats, this is inferential statistics, okay? What we're doing is we're running a test to see whether we're going to accept or reject a null hypothesis. Hopefully you remember the hypothesis is almost always what we think is happening. The null hypothesis is that what we think is happening actually isn't happening, okay? That's in general. Remember I said the p-value in your prac will tell you whether to accept or reject the null hypothesis. So for a hypothesis that people learn better in the morning when they drink 3 cups of coffee, and then the null hypothesis is they don't learn better if they drink 3 cups of coffee. That's a pretty poor example, but I'm trying to illustrate it. And so then the p-value, in this case, you're going to look for a p-value of 0.05 or lower is going to tell you whether you accept or reject the null hypothesis. That's the magic number pretty much for most of this course. P equals 0.05, 5%, okay? The lower the p-value, the more likely that the null hypothesis is incorrect. Those of you working in English as a second language, you will hate the fact that we have double negatives in English, okay? Let's translate that. The lower the p-value, the more likely the null hypothesis is incorrect. The more likely that what we think is happening isn't really happening is incorrect. What? Okay. So what we're saying is if the p-value is low enough, then what we think is happening is really happening. Okay? 2 negatives in English flips it over. Okay? If the p-value is at 0.05 or lower, we're going to say, we reject this, and what we thought is happening, we're going to say there's enough evidence to say it's happening. Okay? I'll keep saying that in different ways. That's probably a better way to say it there. It's very likely that the null hypothesis is incorrect. Okay? It's actually 95% likely that the null hypothesis is incorrect. Okay, Smirnoff, that's why they call it the vodka test, the KS test. What you're doing, the reason I wanted to remind you of null and hypothesis is that for each test, and it's a really good idea to write a summary sheet for yourself in this course, write down the test, write down what the null hypothesis is in that test and what the hypothesis is in that test. Okay? So in this one, the null hypothesis is the data is normally distributed. So this is a test for us to work out, is our data that we got back from our survey normally distributed? We want to know that because then we know which tools to use. Okay, again I said a significant KS value is when we get P is less than 0.05. Okay? Generally, the greater the value of a calculated statistic, the lower the p-value, and the more likely the result is not due to chance. And we'll talk about that next week, these different types of results due to chance. But for this prac, we're focused on being applied and getting through this prac. This is what you need to know. So the lower the p-value, more likely the result is not due to chance, i.e. the result is statistically significant. Okay? What we think is happening is likely to be happening. So in SPSS, you can do that through the Explore menu. You'll have the instructions like last week. By the way, the questions for Prac 2 are now online if you wanted to have a look at those and have a go at them ahead of time. And in this particular example, I wanted to show you, so you've got two very similar tests here. We'll usually use the KS test. Shapiro-Wilk is more powerful, but in general you need to use it with a smaller sample, okay? So they usually say when you've got more than 50 in a sample, it's much better. Well, Shapiro-Wilk, you don't know how accurate it is, okay? So again, they're just, what we're talking about here is it's like two different types of screwdrivers, okay? And you're going to use them for two different tasks. If you know your different types of screwdrivers, a filled head or a flathead, so. That's another course if we go into that. But here you can see, this one is not as powerful. You've got the statistic of 0.065, and then this is the bit significance is also the same as p-value. This is the bit that we're interested in, 0.014, or most interested in. And this one, statistic of 0.986, so you can see it's got a much stronger statistic there, but then we would have to double check if we've got the right conditions in place for that to be accurate. And the statistics there, often what happens in these similar tests is that the p-value is often very similar anyway. So 0.015, so that tells you whether we're going to accept or reject the null hypothesis. What do you think? Do we accept or reject the null hypothesis when we get a result of 0.014? We reject the null hypothesis, okay? The statistic, so the test, you'll see them talk about the KS statistic. That's just the calculated value of this test from this sample, okay? That's why we need to know, well, what does that statistic mean? For the purposes of this prac, just focus on that significance bit there, okay? But I take your point. I'll get some more information on that and see if it's relevant. It's hard to work out what order to present a lot of things in when you're coming at it from an applied angle. Okay, so correct. You reject the null hypothesis. What we think is happening is very likely to be happening, okay? What does this mean then? Are we saying that the data is normally distributed or not normally distributed? You need to double check the null hypothesis, but the data is normally distributed. We're rejecting the null hypothesis. And so we're saying that the data is not normally distributed, okay? Because the null hypothesis says it is normally distributed. The null hypothesis is almost always, explain that last bit again. Okay, so first, that's what I'm saying, you get the test, make sure you're clear what the null hypothesis is for that test. In this case, null hypothesis is that the data is normally distributed. Okay? We run through this test. We find out that P actually is less than 0.05. And so this says that it's very likely that the result is not due to chance. The result is statistically significant. So we're going to reject the null hypothesis. What we think is happening is very, very likely to be happening. We didn't just select that sample and by chance we picked a particular sample that gave us these results. The chance that we did that is very, very low. So we're saying we're going to reject the null hypothesis. The null hypothesis is that the data is normally distributed. I should have maybe put another point on here. The hypothesis is that the data is not normally distributed. Okay? The hypothesis is often phrased. Actually, am I getting? Anyway, for that test, this is the way that it goes. I don't want to go round in circles here. Okay. So you'll see the results, the instructions for how to do this in SPSS, very similar in PSPP, and this is the fourth thing that you need to be able to do for the PRAT. This is the fourth way of checking whether your data is normal or not. And remember I was saying with that other test, the Shapiro-Wilks test, if we've got a large sample, then maybe it's inaccurate, it's hard to know. The way to check that is that you also do what's called a QQ plot to check, and again it's a form of eyeballing, but it's quite an accurate way of eyeballing it, to see if our results, the red dots, fit along what we would expect if the data was normally distributed. Okay, the green line there. Most of what you need to know is that this is quite a powerful scale. Even though that tails off just a little bit, that is evidence that it's deviating from normality. Okay, so the QQ plot is quite accurate because of the scale and the way it's done. Again, you just need to be able to calculate it in SPSS, and then you'll be able to see that. So now you have 4 different ways of testing whether the data from your survey is normally distributed or not. And we need that so we know what tools to use. The 4 different ways are eyeballing, skewness and kurtosis, the KS test, or the Shapiro-Wilks test, and generating normal QQ plots. Okay, we'll go over this again in the tube, so it will become more obvious. But what I want to do for the very last section, the second part of the last section, is what do you do if you then find out after going through those steps that the data is not normally distributed. You're not going to panic because you know there's things that you can do. You don't need to do this in this course, but what researchers will often do is see if they can transform the data so that it then fits on a normal distribution. Okay, sometimes there might be a factor in there that we can add. So if it's on a logarithm or square rooted or some other mathematical transformation, then we might be able to transform it into normal and then treat it as normal data, not with that factor in mind. But in this course, we're going to assume that we're not going to do that second step, and we're going to say that if it's not normal, we're going to use a different type of test. Okay, I'll explain what this means. First of all, we're coming back to that term, non-parametric and parametric. If it's normally distributed, we can use what they call parametric tests, which have a range of assumptions. And I'll go to that in a second. And so non-parametric tests is when these assumptions aren't fulfilled. The main one, is it normal? If it's not normally distributed, we have to use these assumption-free tests. They're not as powerful, and I'll explain that in terms of the different variables that you've already met. So when we're doing non-parametric tests, i.e. the data is not normally distributed, we're looking at ranking the data, okay? So we're looking at ordinal data. Remember we had those 4 different types, that classification scheme. Nominal, the least amount of information. We just know what it is, what it's called. Ordinal, we know what it's called, and amongst a range of those variables, we can rank them, okay? But we don't know much more. We don't know if the ranking is equally apart, and it's not ratio, it doesn't go to an absolute zero. So the sorts of calculations we do on it are a bit different, okay? So we're ranking it. When we say it's not normal, we're going to have to rank it. So we're actually changing interval or ratio data into ranking data. And we know, because you were here in the first couple of lectures, that ranking data, ranked data, or ordinal data has less information in it. So because we're losing that information, we're saying we can't, this isn't normally distributed enough, we can't consider this interval data. We're losing that information, we're giving that up. We're saying we're not actually going to say much about that interval data because it's not normally distributed, okay? So we've converted it to ranked data. They have less discriminatory power because of that. We know that each value is in a particular order, but we don't know how far apart they are. So the statistical power is the ability of a test to find an effect that genuinely exists, okay? Now again, we'll come back to, you might have had type 1 and type 2 errors before. We'll come back to that next week. For the purposes of our prac, you just need to know not normally distributed, got to use a non-parametric test, and that non-parametric test is not as powerful, okay, because we've lost some information there. Okay. Now, just to clarify, non-parametric test, and then this is the parametric data. Parametric data needs to be normally distributed, so we know from before if we found out it's not, we can't treat it as parametric data. There needs to be a homogeneity of variance, okay, so it needs to, well, it is what it says it is, homogeneity of variance across the sample that you've got. It needs to include interval data, and if we're including interval data, then that also includes ratio, because ratio includes interval plus an absolute zero. Go back and look at that slide again if you need to. And our data needs to be independent. So all those need to be fulfilled in order to use parametric tests, which we will do in a later prac. You don't have to worry about them right now. What we're doing now is non-parametric. We've looked at our data, we found out it's not normally distributed, therefore, in your tree diagram, we're going to use some sort of non-parametric test. Okay? Possibly clear? Okay, all you need to know is, again, instead of a screwdriver, maybe this is a hammer, because it's not as powerful test in terms of the results that you get. And this is the one that you're going to use in the prac. It's called the Mann-Whitney Test. Again, a couple of statisticians get their names up in lights. And what we're testing for the difference between means when there are two independent samples, okay? Testing for the difference between means when there are two independent samples. Okay, so just say we have male and female, two conditions with two different subjects in each condition. You can't quite see that p-value off the bottom there, but that's basically what you'll get when you do this test in SPSS. This is the output that you will see. So you go and analyse, non-parametric, pick Mann-Whitney, and you're comparing two groups. This is another similar test, don't worry about that one for this. So Mann-Whitney, and what you're looking for is 0.521 is the p-value. And so would we say that's significant or not? 0.521. And the magic number is 0.05. So it's greater than 0.05. So we would say, well, that's not significant. okay? And then remember, the null hypothesis is what you need to know for every test. Null hypothesis, there's no difference between the means, okay? So we're looking at the age of a sample, then we're dividing them into male and female, and we want to know, is there a significant difference between the age of the males and the age of the females in this sample, okay? We know it's not normally distributed, we did our tests, so we go, well, we can still run a non-parametric test. We'll use the Mann-Whitney test. The null hypothesis is there's no difference. We get this result, which said that's not significant, so do we accept or reject the null hypothesis? We accept it, okay? It's not significant. We don't have enough evidence there to reject the null hypothesis, so we're going to say that what we thought might be happening, that there is a difference, this tests is that there is a difference, it's not happening. Or we don't have enough evidence to say that it's happening. So we're going to stick with the null hypothesis. There is no difference between the means of male and female age in this test. It'll become clearer as you do the prep. Now, analysing categorical data. So before we were doing ranked data, now this very last step in the prac is talking about nominal data. What can you do? Okay, some of you might have seen this before. There's two steps to this in your tree diagram. You could do that, or this might be more of a chain. The first question, and I find this helpful as well, is put it in terms of the question that you're asking, and then say, well, this is the test I would use to answer that particular question. Okay, so first of all, is there an association between two nominal variables? Okay, let's say, again, between age and gender. Is there an association? So we do this chi-square test to say, is there an association, yes or no? I'll explain the chi-square test. The chi-square test, you can just see it as a switch. Is there an association? Yes, no. Okay. If there is an association, that's the second step. Yes, just say we do a chi-squared test, we find out, yes, there is an association. It doesn't tell us anything about how strong that association is, and that's that second test, the Fine-Kramers V test. Okay? Again, make up another name for them, do whatever you have to do to just get it stuck in your head. That this is the tool that I use to answer this question through SPSS. Okay, so just say you carry out a survey with this question, more than 100 participants. You want to, how could you present the data to compare if there's a difference between male and female participants? There's a couple of ways to do it. First of all, as part of this chi-squared test, we do a contingency table, which you've already done in part of Prac 1. So we do that by having two different variables, two groups in two different variables, and we set up this crosstabs, okay? Analyze descriptives, crosstabs, you'll be able to do it. That's in words, so it doesn't make so much sense. Here's an example cross-tabulation where you've got from the Anchorage survey, which we'll look at again in this prac, you've got those different types of parts, and then you're saying male and female, and so you've actually got a table, a 2x4 table here, rather than 2x2. Okay, so that's crosstabs, and this is how you could just eyeball that to see if what you get is what you're expecting. Basically, you're looking at, here's the actual count of 7, so that's how many males answered in the survey that they wanted to decrease the amount of developed parklands. 7, okay. Females, 6. What were we expecting according to this calculation? 6.9 and 6.1. It's not exact, but it's quite close. So we would probably say, well, that's kind of what we're expecting, okay? That the expected value, which is that there's no relationship between male and female and what type of park that they chose, And that's how you work it out if you want to work it out. You do the expected value, so 6.9 is 13 times 133, the row value, times the column value, divided by the grand total, okay? That's how you could do it if you had to calculate it yourself, but SPSS will spit out this table for you, okay? So here's the chi-squared statistic that then does something more with that table, okay? It tests whether there's an association between two categorical or nominal variables, gender or athletic club membership. Okay, first of all, it sums the difference. Again, you don't have to do this from first principles, but the test is summing the differences between observed, and expected counts. That's how you do it in SPSS. And then people often write it like x squared, that's the chi-squared statistic. If it's less than 0.05, then there's enough evidence to reject the null hypothesis, okay? Reject the null if it's less than 0.05. Chi-squared statistic, here's your cross tabs, and then you do the chi-squared statistic, and this table will come up underneath. There's the calculated value, and what you're interested in is the significance level, the p-value. The p-value is 0.96. It is way, way above 0.05, okay? So we are going to accept the null hypothesis, okay? It's not below 0.05, so we cannot reject the null hypothesis. There's a few assumptions as well. We'll go through this. If these assumptions aren't fulfilled, then you need to say that when we did the chi-squared test, we cannot be certain that the chi-squared test is accurate, okay? You need these assumptions. They're pretty basic, but now I'll just go through this. Null hypothesis is there's no relationship between the two values. So in this situation, we couldn't reject the null hypothesis, so we're saying we're running with this. There is no relationship between male and female and the way they answered that question in the Anchorage survey about different types of pathway. No relationship. Didn't matter significantly. Statistically, didn't matter. The p-values was less than 0.05. It is significant, and we reject the null. That didn't happen. So we did not reject the null hypothesis. If it is significant, i.e. if we do reject the null hypothesis and we say the hypothesis is actually happening, that's where we're saying there is an association, there's some sort of connection between your gender and the way you answered that question in the survey. The chi-squared test says there's some sort of association, but it doesn't tell us how strong that association is, remember? These are the assumptions. Make sure you have a look at that before the prac. You need to have, down the bottom here, it will tell you whether the assumptions were fulfilled or not. You need to check that in 2x2 tables, all expected cell counts are greater than 5, be greater than the 5, excellent. And if they're larger, this one was larger, remember it was a 4x2 table, you can have up to 20% below 5, but no cell should have an expected count of below 1, expected frequency of below 1, okay? Have I got it there? No, I'll show you in the prac, it will be easier. But when you look at that cross tabs and you look at the expected counts, you just test. Do we have the situation that we need to have to confidently say that the chi-squared test is telling us something accurate? Okay, it's an easy mistake to make where you say this is the chi-squared result, but if those assumptions aren't fulfilled, you need to say, well, this is the chi-squared result, but we can't be sure if that's accurate. We can't really use that because the assumptions weren't fulfilled. assumptions are violated. Okay, so going backwards. Remember I said there's two steps to this. One is there an association? Yes or no? That's the chi-squared test. No, there's no association. Fantastic. Yes, okay, there is an association, but how strong is it? This is what this test does. So if we did get a chi-squared test, a chi-squared result that was significant, yes, there is an association. We would use one of these two tests to decide how strong it was. Again, you press the right button in SPSS, it gives you the results for both of these. You just need to know which one to read. If it's a 2x2 crosstabs table, you read the phi statistic. If it's larger than 2x2, you read the Kramer's V statistic. They're very similar. Remember I said often we have two similar tests, they'll give a very similar answer, but sometimes it can be meaningful, the difference. All right, what do you have to know about this test? Again, this time we're picking up a saw or something like that, I don't know. The values range from 0 to 1 when you see the figures spat out from this test. 0 to 1 about how strong that association is. Okay, so here's an example. We've got the significance, the p-value, 0.410, and it's ranging between 0 and 1. Show of hands, who thinks that that is a weak association? Who thinks that's a strong association? Who thinks it's a medium association? Non-participation. All right. You're allowed to just have a guess sometimes. I would say that if you've got a scale between 0 and 1 and you come in at 0.4, it's sort of roughly in the middle. So that's sort of a medium strength association. Oh, that's funny. All right. I displayed that slightly wrong. And here's a table to help you with that. In general, in stats, when we have a scale between 0 and 1, you could say that 0 to 0.3 is a low association or a low result, depending on what you're looking at. In this case, we're measuring strength of association. If it's between 0.3 and 0.7, we generally say, well, that's mid-strength. It's somewhere in the middle. Above 0.7, in this case, it's a strong association. And then number 1, you would say there's a near complete association. Okay? That's basically what you need to know to go through those steps. So again, chi-squared test, is there an association? Yes or no? If yes, how strong is that association? Use this to work out how strong the association is. The final thing to say today is that it's good to get in the habit of how you report results. First of all, you might have to read a paper and understand all the terminology in there. And secondly, I want you to practice presenting it like this, okay? So if you're presenting, say for instance, a standard deviation, the mean and the standard deviation, you would say, here's the mean plus or minus the standard deviation, because standard deviation can go either way. In this case, you present it like this. The x-squared statistic, 3.4. Degrees of freedom, I'll explain that later, we're out of time, but that will come up in your, I'll explain in the tutes. It'll come up in the output window. You'll see DF, degrees of freedom, and then you give the p-value of whether it's the p-value for that, okay? I'll explain that more in the tutes. We'll step through it. These next couple of tutes are going to be really the toughest part of the course. So you've really only got 3 lectures on stats, 2 more to go, and then we keep revising that over time. Okay, so if you have time to very quickly now, let's get people together and see if we can find a time that I can then put on Blackboard for when those groups are happening. I know it's 10:02, so let's do this really quickly. We were going to get revision groups that want to meet on a Tuesday or a Wednesday. top and bottom. Revision groups that want to meet on a Thursday, and then the extension groups can meet here. Okay? If you just want to go with whatever times people come up with, take off now and look at what gets listed on Blackboard and see if you can fit. Okay. So quickly get into those groups and I'll come around and see what sort of times might work for people. Okay? Here in this one, okay. Yeah. What about an hour? We're going to set one up straight after the lecture. Okay. What about early afternoon? What about 12 or 1? Alright, who can't meet straight after the lecture? When can you meet? No, who cannot meet straight after the lecture? Alright, you guys get together and see if you can find a time that works later on Thursday. Come and tell me or send me an email. Put your hands up again. Thursday, you cannot meet straight after the lecture. Wants to meet on Thursday. It's 3 of you. Quickly meet. There might be enough for group. Okay? You guys meet, find a time that works. Everyone else has to put in a Thursday straight after the lecture. Okay. Tuesday, people, did you find?
Presumably you're not coming to Bells, yeah? Like it's not
No.
Yep.
Yeah. Yeah. everyone. Thank you. I've got some times for all those groups, and we can post them on Blackboard, and we can make sure that they start happening. We've got a revision groups that's going to start after the lecture on Thursday. We've also got an extension group that's going to start after the group on Thursday, and I'll make sure I list those up there. If there's no time that works for you, then just jump on Facebook or talk in your pracs. See if you can just grab at least 2 or 3 other people and meet at a time that suits you, okay? Talk about the material from each week and send me questions or put muddiest points on that link so that we can keep everything moving forward. Okay, thanks everyone. So you were asking, so you have that survey question, so you have 2 variables. One is types of part and one is gender, okay? And you want to know, is there, you do a chi-square test and you find that the way people answer the types of parks, there was an association between the way they answered it and whether they were male or female. Okay, so that's the chi-square test. It just finds out, is there some sort of association? Yeah, there's some sort of statistical association there. And then the last test is, okay, if there is an association, is it a strong or a weak association? Because the chi-square test just tells you if there is or if there isn't. Okay? Thank you. No worries. Alright. Yeah. Yeah. Yeah, that's fine. So you will be able to, when you've done practical 2, you should be able to upload it to